So the scientific notation section gets kind of lumped here just because it involves exponents and sometimes negative exponents. And you're going to see this if you haven't taken any science classes yet. You will see it in whatever science, whether it's astronomy or biology or physics or chemistry or anything. Scientific notation permeates all the sciences, hence its name. So just real quick, just want to give you a quick overview on how to write numbers in scientific notation and how to interpret numbers that are already written in scientific notation. So in general, a number is considered written in scientific notation when it's expressed like this. You've got a number times the power of 10 that number is. Here's the thing about this number A. The number A will always have only one non-zero digit to the left of the decimal place. That's what this means right here, that the absolute value of A is going to be bigger than or equal to 1 and strictly less than 10. What that's saying is there's going to be only one non-zero digit to the left of the decimal. If you have a 0 to the left of the decimal, if you have 2 digits, that is not scientific notation. Okay, so just be careful when you're doing that. One of the good uses and purposes of scientific notation is because you're writing everything in a common format, you can then easily compare magnitudes of numbers. So if you're in an astronomy class and you're looking at how far away different stars are, it would give you a quick and easy way to see, oh, that is 10 to the 2nd light years away, and that one's 10 to the 5th light years away. So you could quickly and easily look at the magnitude of a number. Okay, so it's not all that difficult to write numbers in scientific notation. So here's my example. We're going to write the following number. This is the number of miles that the Earth is away from the sun usually, 93 million of them. So we're going to write that in scientific notation. So the first thing that I'm going to do is I'm going to write the number part of this. And so all you do is you approach the number from the left, and the first non-zero number you hit, that's it. So that's 9. So I'm going to write this as 9.3. Not 93. If you write down 93, that's going to be wrong. It's not scientific notation. If you write down 0.93, that's wrong. You have one non-zero digit to the left of the decimal place. Then times 10. And now I'm just going to count how many powers of 10 is that. So I just count over here. I'm going to count the decimal places. So it's 1, 2, 3, 4, 5, 6, 7. It's 9.3. The way you might say this is it's 9.3 10 millions. But 9.3 times 10 to the 7th. That is the scientific notation of that number. So with that in mind, go to the left and do that exercise. 243 billion. Please write that as scientific notation. So as I approach this number from the left, what is the first non-zero digit that I hit? 2. So my number part is going to be 2.43. Always just one non-zero digit to the left of the decimal. What do you think is the most common mistake students make on the tests when I put a couple of these? Putting more than one digit to the left of the decimal. That's why I'm saying that, not to be annoying, although that might be true too. Okay, but I'm just trying to make sure you remember that. Only one non-zero digit to the left. And then now my power of 10, my magnitude. And how many places do I jump to get to the decimal behind the 2? 3, 6, 9, 10, 11. Yes, great counting. I appreciate that. 2.43 times 10 to the 11th. Anybody confounded by that? All right, my next example. Just want to make sure I'm covering all the bases here. So now I have a really small number that I want to write in scientific notation. So again, I'm going to approach the number from the left. What's the first non-zero digit I hit as I come from the left here? 6. So my number part is 6.7 times 10. Now, this is a small number. It's a fraction. And so we just learned in the previous section that the way you represent fractions with exponents is using a negative one. Okay, so I'm going to count my places. My eyes are 50 years old, so forgive me. 1, 2, 3, 4, 5, 6. So there we go. 10 to the negative 6 power. It's negative because that's a fraction. It's a small number. Please do the same thing with the exercise right next door. As I come at this number from the left, what is the first non-zero digit I encounter? The 1, so it's 1.31 is the number part. Then again, I notice this is a small number. It's a fraction. So my exponent's going to be negative, and it's going to be negative how many? 9. -9. I'm going to trust you. Should I trust? Is that good? All right, good. That's a lot of small numbers for me to count. So I'll embarrass myself there. All right, so all we're going to do in the next couple problems is just the backwards process. So the next problem is 6.93 times 10 to the 7th. I want to write this in standard notation, meaning write it just as a regular number. So again, my exponent's positive. That means it's a big number. So here's my 6. I'm not going to write the decimal 693. I'm going to now count 7 places from where the decimal is to where it's going to be. So I'm going to start my pen between the 6 and the 9, and I'm going to hop 7 times. So 1, 2, 3, 4, 5, 6, 7. And at each of those hops, I'm just going to fill it in now with a 0. So 0, 0, 0, 0, 0. You can check again if you want to make sure that that's 7 hops, but I believe I did that right. 1, 2, 3, 4, 5, 6, 7. Now the decimal in standard form is after that last 0. I don't need to write it. There we go. I've got, what is that going to be? That's going to be 69,300,000 is my number there. So give your best try to the next one. 4.05 times 10 to the 4th power. The decimal right now is between the 4 and the 0. So my challenge now is to move that decimal from between the 4 and the 0, the appropriate number of hops. And so it's going to be 4. And since this is a big number, I'm going 4 in this direction. 1, 2, 3, 4. So I need to add on how many zeros at the end of that number? 2 more zeros. Yes, that gives me the 4 decimal places. So 4.05 times 10 to the 4th can also be written as 40,500. All right, here's my last problem for the day, and then you've got just 2 more. You're almost done with me for the day. Congratulations. The next one is 4.75 times 10 to the negative 6th. So again, my clue here is that because that's a negative exponent, this is a fraction, it's a small number. Okay, that's what sets off the neurons in my brain that I'm going to move the decimal in a different direction. So I've got my 4, oops, I don't want that. I've got my 475. The decimal right now is between the 4 and the 7. So I'm going to now move it 6 places in the fractional direction. So I'm going to go 1, 2, 3, 4, 5, 6. And my neatness is just exceptional here. So sorry about that. I wish I had some white out. So now I'm going to add in the zeros, 0, 0, 0, 0, 0. I'm going to put the decimal here. If I had the room and I wasn't so messy, I'd put a 0 in front of that decimal. but we'll practice that on your problem in just a minute. So notice I had to move the decimal 6 places. That means I have 5 zeros there in front of the 4 now. So please do the same thing for the one right next door, 2.3 times 10 to the negative 4. So I've got my 2.3, so 23 right there. And now, again, this is a negative exponent. That means I'm going to have a fraction. I'm going to have a small number. So I'm going to move that decimal from between the 2 and the 3, and I'm going to move it 4 places to the left. So I go 1, 2, 3, 4. That means how many zeros are going to be in front of the 2? There's going to be 3. And then your decimal point. Now, I'm not a stickler for this. If you leave the number 0.00023, that's fine, but it is proper notation to put a 0 and say there's no whole numbers, there's no whole part to this. All right, the last one is just another writing a number in scientific notation. I just wanted to show you the difference between a negative number and a negative exponent. This negative out in front of this problem right here, which you see because now the computer is hung up. Oh, now we're back. Yes. For the last problem, this negative out in front does not affect the exponent at all. It means the number's negative. So 30 seconds, write that in scientific notation, and then you will be done with me. What's the first non-zero number I hit as I approach this from the left? The 9. So you're going to have negative 9.76. Okay, nothing about my process has changed with the negative number other than there's a negative out in front times 10 to the, and how many places have I gone? 1, 2, 3, 4, 5, 6, 7, 8. Great counting. I appreciate that. I appreciate you being here.